Hey Thinksters, welcome to the part 1 of the OpenCV tutorials. In this tutorial, we are going to begin with knowing how to work with images. So that includes how to load images using OpenCV and how to do the basic manipulations such as converting color channels, how to save image, how to resize it. You're going to find them useful for the computer vision operations that you do in the future. And then to make things more fun, we are going to also learn how to draw shapes on the image. And then we are going to end this tutorial by drawing shapes directly, live drawing on images. Okay, let's begin. First of all, I would advise you to create a virtual environment just for this tutorial series. If you're working on Windows and if you're using Anaconda, that's the best way to go. You just have to go to the environments, create a new virtual environment, and then at the Home tab, you can just choose applications on your choice of virtual environment, and begin. And for all the things that you installed on this virtual environment, it will not fight, it will not interfere with all the other applications that you have. And for this tutorial, we are going to use Jupyter Notebook mainly, but feel free to use the other things like VS Code, PyCharm, whichever IDE that you're familiar with. First of all, we are going to need to install the OpenCV module. OpenCV it's available in Python, so Python is sort of like a wrapper for the native OpenCV, which is written in C++. For all of the operations that we are going to do today, we will mainly use OpenCV. But also, it's also useful to install NumPy and Matplotlib, because for NumPy, you get to manipulate the images after it is being loaded on your script. OpenCV will convert image pixels into NumPy arrays. So it converts from a color intensity to a range of numbers, and then because it is loaded in a range of numbers, it makes any kinds of computations easier. And for Matplotlib, because we need to display the image, and most of the displaying parts will be done by Matplotlib module. So first of all, just go ahead and install this 3 modules, and note that you can access this notebook as well as the notebooks of all the other series from a GitHub link that is provided in the description below. Okay, go ahead and execute this, and after execution, you're going to import those modules. Import NumPy as NP. I'm sure you are familiar with that. And then import matplotlib.pyplot as PLT. For those who are seeing this as NP as PLT for the first time, it just means that we give it a different name, usually shorter, to make our coding process faster. And next, import CV2, which is the OpenCV. And then there's a magic command, matplotlib inline, we do this only on Jupyter Notebooks. You don't have to do it on any script. That is to display the plots at the display cell, at the output cell of Jupyter Notebook, instead of displaying the images on a separate pop-up window. Okay, we are going to do the first OpenCV operations. Load and manipulate image files. I am using an image from this link. It's from unsplash.com. It's a Creative Commons free. If you are using that not for commercial purpose, I believe, you can feel free to use your own images for this tutorial. But if you would like to use the same image as I use, it's available at this link. First things first, we import the image. We load the image from our directory into the Jupyter Notebook. So what do? We do imread. So take cv2.imread and then the directory of your image. For me, my image located in a folder in my current directory. So I'm using a relative path in a folder called figures. And then inside the folder, there's this file. There's this JPEG file that I want to load. It's called figure 1. And I load it into a variable named img. And as we can see, when we do the type, means that we want to know which is the data type of this variable, and it returns numpy and the array. So we know that it's an array, and then we type image.shape to know the dimensions of the image. And then the output says 5,632, 4,274, and 3. It means that the height of this image is this much. The width of this image is this much. And there are 3 layers. So there are 3 more dimensions. The depth is 3. It means that on the first dimension, I should say, for OpenCV loads image in the channels of BGR, so blue, green, and red. So on the first layer, it is blue. So all the shades of blue of 5,632 times 4,224. And then the second layer will be green. It's of the same dimension. And the last dimension is the red dimension of the same width and height. So we can know that if you see a third dimension here, you can be sure that it's a multicolored image and not grayscale. And it's the time to show the image. I'm going to show you 2 ways of showing the image, one using OpenCV and the other one using Matplotlib. So showing OpenCV, what you have to do, showing image using OpenCV, what you have to do is to type out the method .imshow and then give the window a name. For me, I give it figure. And then the variable, the numpy, the image array. And then you'll need to type this .wait key so that your image does not pop up and then disappear immediately. So wait key is that the image will be shown and it will be closed when you proceed to click the close button. So I will show you here. I will execute this again. And then there's a pop-up window. Excuse me, it did took some seconds to load. That's why I paused the video for a while. And now you can see that it is a very huge image to be fit on my small display. Yeah, and I'll proceed to close it. And so, one of the things about using OpenCV to show a figure is that if your figure size is too big and you didn't resize it when you display it, it potentially may be too large and it is not actually resizable. The window is not resizable. And that is why we proceed to move to the second solution of showing images, which is using matplotlib. So what you do is, because just now we used the magic command of matplotlib shown in line, it will be shown in a output cell like this instead of a separate window. So what we have to do now is say matplotlib plt.imshow is the same. I think it's the same imshow method as OpenCV, and then put in an image. Then the image will be shown here, no hassle. But there's one caveat. It is that, as mentioned before, OpenCV OpenCV processes or loads images in the channels of BGR, while matplotlib displays images in the channels of RGB. So you can see that this image has sort of like a weird color representation. And now you know why. The reason is that the red is swapped as blue. The blue is mistakenly taken as red. The red and blue, the channels, they are swapped basically. And what do we do about that? We convert the color channels. For that, we can use an OpenCV method called convert color, CVT color, and just plug in the same image variable and then say cv2 dot color underscore BGR to RGB. Actually, when you see cv2 dot color, it has many other choices. So BGR to RGB, but there's still like many other choices. To look at the full list, you can just press tab on an unfinished method statement, and then all the other suggestions will pop up. So feel free to explore with that. And later on, maybe you want to say BGR to gray or BGR to HSV, different color format. Yeah, it's all available in OpenCV. But in this case, we want color underscore BGR to RGB. And then we assigned it as a new variable, image underscore RGB, and then we display this RGB image. And now we can see the color is back to the normal. Okay, just now we briefly look at BGR to gray. That is like after the image is being loaded as in OpenCV, but we can also load images from color as grayscale in OpenCV. You don't have to do another operation. You can just directly load it. And that is when you read the image using the same method, imread method, and after you pass in the image directory, you can say cv2.imread underscore grayscale. That's also another way of doing it if you don't want to. I mean, this is easier to read, right? People know what you're talking about, what you're doing here. when they say imread underscore grayscale. People know, well, the next developer or or you half a year later will know what you're doing here. But otherwise, if you want it fast, you can just replace this whole thing as 0. It's the same thing. And then you can load it as image grayscale. We assign it a new variable, and the shape becomes only 2 dimensions. There, it contains only the height and the width, and no 3 dimensions anymore. But yeah, you may see that it's still colored somehow when I display it from Matplotlib. It's like image grayscale, but it looks kind of greenish, bluish. It's not gray at all, and that is because Matplotlib doesn't display it as a grayscale if you don't explicitly state it. Because the default color mapping of PLT is this one. It displays shades of numbers or shades of colors from a color palette of bluish, greenish palette. And that is why you'll see that, why is it green after I converted to grayscale? It's not your fault. You just have to define a color mapping of gray when you want to display it from Matplotlib. Because just think about it. The computer doesn't know which color your images mean. It just sees a bunch of numbers. You have to define the color channels to those numbers so that your program knows which color to take, and the numbers are just the color intensity or the color brightness of it. And that is why for BGR color image, it can be mistaken as RGB color image. Yeah. And then after you display it as CMap gray, then it shows a shade of gray. So far, so good. Then let's move on to image resizing. Image resizing will be super useful in your OpenCV life trajectory. You're going to come back to it again and again. We are going to use the color image RGB, and then the shape is, just to remind you again, is 5,600 something height, 4,200 something width, and 3 color channels. And we use the resized image of OpenCV. We use the resize method in OpenCV to resize image. Is as straightforward as that. Put in the image variable, image RGB, and then specify the size, any size that you want. I would suggest to retain the aspect ratio by doing it in a math operation. If you want half the size, then divide the width and the height by 2 instead of, let's say, because now we pass in both the variables as the dimensional size, width and height, and then you can see that the width is 4,224. You can of course pass in 2,000 as width and 3,000 as height, but the aspect ratio will be broken. It is best to say 4,224 divided by 2, and then height divided by 2. Then you will know that only the scale is different, but the aspect ratio is the same, and the whole image will not be distorted. But in my case, I want to make the image distorted. So I say times the width by 2 and then make it half the height. So when we show the image, it looks like this. This is just to show that you can pass in any image size that you want. Next, we are going to look at flip image. Flip image is useful, especially in machine learning operations when you want to increase your data size. For some for some machine learning operations that when image manipulations, when image flipping and image resizing does not matter so much to the outcome, you can actually increase the sample size twofold, threefold by generating more images by just flipping it around, because you can flip it in any direction that you want. You can rotate it in any direction that you want. So yeah, it's a good way to generate extra images. So which method do you use in OpenCV for flip images? Is .flip, and then pass in the variable. And then you have 3 options here. If you wanted to flip vertical, you pass in the value of 0. Horizontal, pass in the value of 1. And -1 is that you want to flip it vertical and then flip it horizontal. And then I pass in the value of 1. When the image is shown, the output variable is an image that is flipped vertical and then flipped horizontal. So just to compare that with this image. Okay, so far so good. And then this is very important to save the image. You want to save your hard work. So what you have to do is type in .imwrite and then pass in the directory that you want to save the image, as well as the image name. In this case, I want to save the flipped image. I said figure 1 _ flip, and not forgetting the image method, image format. You can put it JPEG, PNG, whatever. Next, this is a nice to have feature. It can maybe make your life easier. It is to adjust display size. Note that this is not image resizing. You do not doing this does not affect the image size that you're having, but only the display size. Maybe you want to just view the output cell bigger. You want the image to appear bigger on your output cell. Then you use this. The most important thing is you define matplotlib.figure, and inside the figure you pass in the size of the figure that you wanted to show, and the size is by inches. So 10 × 8 inches for the whole image, and then pass it into this variable. And for this variable, you say add subplot, because for matplotlib, you can add however many plots that you need. In this case, we only want 1 plot. So it means, 1, 1, 1 means that I want a subplot containing 1 row, 1 column, and this image itself that I'm going to manipulate is on the first position. And pass it there as AX variable. Then AX.imShow, pass in the image itself. You can pass in any image, and then it will appear bigger. Okay, first section is done. Next, we are going to do something more fun, which is to draw shapes on an image. For this, we define a blank canvas. For this, we use numpy.zeros of shape 512 times 512 times 3. Make it a data type of integer 16. It means that we are creating quite a small canvas containing all 0 values. So all of the values in this canvas, 512 times 3, is all zeros. So the canvas dot shape is the shape that we define, and when we see it, it's all 0. So when it's all dark, means that all the values are totally at the bottom at 0. And then first we are going to draw a rectangle. So naturally we put in dot rectangle for OpenCV, and then we pass in the image. The image itself is the canvas, and then you define the first point of your rectangle, which is the top left, and then you define the second point of your rectangle, which is the bottom right. Okay, so first point is top left, second point is bottom right. Okay, so this is the opposite direction. And then the color you pass in, because it is RGB image, the canvas, then you can pass in, is it the RGB image? RGB? Yeah, it is red, so it's a RGB image. The thickness is 10. Means that how thick you want your rectangle to be. Note that we are not, define, let's say, new canvas equals to the outcome of CV2 rectangle. We are not doing this because all of the shapes operations, shape method of OpenCV change this image in place. It will foreverly change the image itself. It just changed the original image. And so when let's say this canvas is 512 times 512, and then I said I want my top left point of the rectangular to be 10, 10. So it goes like this, like 10, 10. This is the first point. And then I want my second point to be 150 and 100. So it goes like 150 and then 100. So you will see a rectangle at this point. And so it returns an array, but you can, it is easier to be displayed on an image, and then you can just see it with your eyes, and then you can see the image. You don't show like new canvas or something, you show the original image, and then you see a change has been taken place here. A red rectangle is being drawn. And next one, we can proceed to draw a circle. A circle, you use dot circle, obviously, and then you pass in the same image, and then you define the center of the image. The center point of the image here is 300 times 300, so 300 times 300, with a radius of 50. The radius means how large do you want the circle to be, measuring from the center itself. Okay, so the radius is 50, and the color, red, green, blue, so 255, like 0 is 0, is no element of these channels, so 255 is the intensity of the green channel, so we are going to get a green circle. The thickness is the same, thickness of 10, and when we show it, show the canvas, you'll see a green circle on top of the rectangle. What if we want to draw a filled image? So this is like a filled circle. The only thing that you change is the thickness. You assign the thickness of -1 to fill it all. And this does not only apply to circle, but every shape. You can draw a filled rectangle, a filled polygon by giving the thickness value of 0, 1. As easy as it is. Next, we are going to draw a line. Naturally, the method name is dot line, and then same thing. Put in the image. Put in the canvas as the image. So point 1 here is the beginning point of your line, which I put it like 200 and 100 here. This is the beginning point. And then the second point is the end point of your line. And here the value is 400 times 100. So 400x and then 100y. The color is blue, red, green, blue channel, 255. Thickness is the same. And as usual, we show the canvas and we see a blue line here. Okay, after drawing shapes, it is time to write some text. The outcome is that I put a text of happy here. For put text, first you define the font. There are many fonts to choose in OpenCV. Yeah, but the default font can be Hershey Simplex. Yeah, don't have to overthink about the fonts, actually. cv2.putText is the method name, and then pass in the same thing, but then write text, you have to put in the text variable. In this case, I put happy, or RG is actually the bottom left of the text box. So this is the pointer where you say where do you want the bottom left of your text box to be. In this case is 5400. So 5400. This is the bottom left point. Font face, you pass in the font variable. Font scale is the font size. And then the color, because you have the maximum brightness of all 3 channels, so it will be a white color. Thickness is 5. Line type doesn't matter. Yeah, and then you matplotlib.imshow the canvas. You'll see the change happens in place. And then if you have special needs to not only draw the regular shapes but a custom polygon, you can actually do it here. What you do is first define the vertices of your shape. In this case, you define a NumPy array first, and then you make it a multi-dimensional NumPy array. So you make it like a list of lists. So you make it a list, and then inside the list you pass in the location of each vertices. Now I have 4 vertices, 1, 2, 3, 4. So yeah, these vertices, it is a list of lists, and then I convert it to a NumPy array of type integer 32. And vertices.shape is 4, 2, means it has 4 vertices, and each vertices has 2 coordinates. And note that this is a NumPy array. It has nothing to do with OpenCV yet. And here we do a peculiar operation, which we actually reshape it and add a 3rd dimension to the vertices, to the vertices array. From 4, 2, we make it to 4, 1, 2. So basically we say, add a special dimension here, and then the new shape is 4, 1, 2. The reason why we do this is because OpenCV needs it to be in this kind of dimensions. Not actually OpenCV, but the polylines method needs all the points of the polygon to be in this kind of dimensions. So the method name is polylines, and then you put the canvas as the image, and then you pass in the points. It is already 4, 1, 2. Another peculiar operation is you pass it as a list of numpy arrays, which is a list of lists. Yeah, it's a little bit weird, but it needs it. Okay, so bear that in mind, or just look at the documentation. Is close equals to true means that you want all lines to be connected together. Color, again, white, thickness of 5. Then you see there's a white polygon containing 4 vertices that are connected together. Okay, so far so good. We have already finished the second section of our first OpenCV tutorial. Now we are going to do something more exciting, which you get to draw on an image with your mouse cursor. I think it is better for me to show you how the outcome look like before I show you how to do it. Let me execute this. So this is a canvas that you can draw white rectangular and then escape. I think there is another thing that I want to show you, because this is draw rectangle. Another thing that I want to show you is draw circle, which, let me execute this. So when I click on the left side of the mouse, it will create a red circle. When I click on the right side of the mouse, it will create a blue circle, as such. Okay. So after you see the outcome, let's see how are we going to do this. Okay, first we define a function that's called draw circle. And don't worry about all these parameters. These parameters are what will be passed from the event later when you, let's say, click on the mouse. Those information, they are generated automatically by the event callback and then passed to this function itself. So draw a circle per mouse click, blue circle for left button, red circle for the right button. And the event is the variable that contains the mouse click itself. Then we say if the event equals to cv2.event left button down. So this is what is already there from OpenCV. It just means that if the event is a left button down, if you click on the left side of your mouse, then do this. Else if the event equals to event R button down, which means right button down, then do this. So just now I've demonstrated for the left button down, we draw a blue circle. So cv2.circle, you've learned this just now. Pass in the image, define where's the center and radius of the circle, and then pass in the color. So red, green, blue. It's a blue circle of thickness -1, means that we want it to be a filled circle. If the event is a right button down, then also create a circle. And what is different is just the color. So make it a red circle. Okay, the function is just as simple as this one. And then to make it a live interaction, we first define a window with a name. because this name will be referred to the next operations. So define a string, which is a window name, a variable, and then pass this variable to cv2.named window. Win name equals to win name. Means that you create a window with a name, and then canvas equals to mp.zeros. You just define a black canvas of size 512 times 512 times 3. And then cv2.set mouse callback. It means that you want to connect this callback. Like, callback means that when something happens, let's say when you move your mouse, this callback will constantly detect for these operations, and it will do something whenever the mouse is clicked. Means that means that there is a character, let's say a character that keeps listening to these operations, and when something happens to these operations, a mouse click, then it will do something else. Okay, so you also pass in the same Windows name, and then you pass in the function. Note that the function contains no brackets like the normal Python ones. It's just the name of the function. Draw circle. And what this line does is to connect the callback with the function. It says that if you heard a mouse operation, if you know that the user's mouse is doing something, then ask the draw circle function to do something with this window. Okay. While true means that keep showing it unless stated otherwise. cv2.imshow, show this window with this canvas. It means that display this canvas with the Windows name canvas. We've seen this before, imshow. This is a bit peculiar. If cv2.waitKey20 and 0xff equals to 27. The way to understand it is if cv2.waitKey, if the window has been open for at least 20 milliseconds, and at the same time an escape key is pressed, like this is the listener. This is a 27 is the hex representation for an escape key, I think. Let me check. Okay, did a little bit of research and I would like to correct myself. Here the answer says 0xff is a hexadecimal constant, which is this in binary. It means that 0xff is a hex representation, and if the hex representation is equals to 27, which means it is the escape key. So this line just means that if the window is opened for at least 20 milliseconds, and if the escape key is pressed, so it detects a key press of exactly escape key, then break the while loop. It means that stop this operations. And after it stops this operation, it breaks out of the loop, says cv2.destroy all windows. It means that don't run even in the backend operations. Okay? So it's quite lengthy here. Let me recap. First, drawing a circle, you define a function with all these parameters that are being passed by set mouse callback. So don't have to worry too much about that. The main thing is if the event is a left button down, then draw a blue circle. If the event is a right button down, then draw a red circle. Yeah. And then here you define the name of the window, and then you create a new window, you create a blank canvas, and you set the mouse callback to connect the window and the function, the draw circle function together. Means that there is something that monitors the mouse click, there's something that draws the circle according to the mouse click, and the circle is drawn on the window. Well, true, it's a loop, so it will keep showing the window with the canvas no matter what change it has until you press the escape key, then it destroys all windows. Okay, so let me execute this again. So for the left button, it creates a red circle. For the right button, it creates a blue circle. So yeah, I'd like to correct myself. Left button is a red circle and the right button is a blue circle. I guess I mixed up the RGB and BGR channels here. And note that when you click close, it will still appear again because you only break the loop when you press the escape key. So when I press the escape key here, then it breaks the loop. The loop is break. When you click the close button of the window just now, it does not break the loop. Okay. So similarly, we are going to next draw a rectangle. It's the same. You have a draw rectangle function, and then the mouse callback is set to draw rectangle. The other thing here remains the same. See, Windows name canvas, name window, the same canvas shape, and then the same loop. And this loop is also when escape key is pressed, you show the canvas. If escape key is pressed, then break the loop and then destroy all windows. So the only thing that's changed is this draw rectangle. First, before the draw rectangle, because we want to keep drawing new rectangle on the canvas, so we set this is drawing equals to false. It's a flag, it's an indicator. So the IX and IY, we put it a temporary initializing value of -1. So we call this three variables is drawing IX and IY by saying global, so that we can alter the global variables. And here we have three else if statements. The first one, if event equals to cv2 dot event left button down, it's the same thing. Here we activate the drawing. It means that, oh, now you can draw. By setting is drawing to true. And then setting the XY means that the current X location and the Y location means that the current coordinate in X and Y, you assign it to IX and IY. Okay, so imagine when you see a blank canvas and then you click left button down, it activates the drawing. And then it will go onto the, and then it will loop through and then come to, and then until the next operation is called. So if it is not the left button down, if the event is mouse move, means that after you click on the button, the drawing is activated, and then you start dragging your cursor. When you drag your cursor, the event will be detected as mouse move. And then when the mouse is moving, if this is drawing is true, means that you already click on the left button before, then draw a rectangle, which the first point is the current point. The first point is the point where you started the first click here. So when the left button down is being initialized, is being clicked, then it initializes the first location. And then this first location is the first point, the top left point of your rectangle. And then the second point is your current location. So as far as your mouse is dragging, new rectangle will be created. And then the bottom left of each triangle is where the mouse is dragged. This is the second point. And the color is white. The thickness is 1, means it's a filled rectangle. And next, when you're done drawing, you'll for sure lift your mouse button. So event left button up means that you are no longer drawing. Then deactivate the drawing. Why do we need deactivate the drawing? It's because we don't want the rectangle to be mixed up together. When you lift the button, means that you're done drawing one rectangle, and then the next mouse button down will be a new rectangle. So is drawing equals to false. cv2.rectangle, if your button is up, you still draw the last rectangle for wherever the location it is stopped. But then most importantly, you set its drawing to false, means don't draw anymore. Okay, so as a recap, this draw rectangle, everything is the same here. Setting the canvas and the mouse event callback is the same. And for drawing rectangle, you have 3 different actions to perform. When your mouse is being clicked down, you start drawing. And then when you move your mouse cursor, you draw each rectangle as it goes. And when you leave your mouse button up, means you're no longer drawing, and then stop the drawing. And let me demonstrate again. Let me execute this. So when I click the button down, and then when I drag it, it just forms a new triangle, rectangular, and then I lift my mouse button up, then it forms a rectangle. And then the second one will form another rectangle. Okay, so it's just this. And as usual, I have to press the escape key to stop it. Okay, that's it for the tutorial today. I hope this makes a very good journey for you in learning OpenCV. Yeah, for the next one, we are going to see how can we work with videos, loaded videos, how to record the videos, or how to display videos. Okay, it's going to be fun. If you need some additional resources regarding manipulating images using OpenCV, feel free to watch this YouTube videos, which I have created before on Finster. Okay, see you in the next one. Enjoy your day. Goodbye.